कम।
नहीं, अभी शुरुआत आपसे ही करेंगे सर, आपके।
अच्छा ठीक है। ओम यं विधाम देवगणाः पितरश्च उपासते तया मध्य मेधयाग्ने मेधाविनं कुरु। ओम सत्यं बृहद्रुतमुग्रं दीक्षा तपो ब्रह्मयज्ञः पृथिवीं धारयन्ति सा नो भूतस्य भव्यस्य पत्न्युर्लोकं तृणातु। मैं हिंदी में बोलूंगा।
यस सर, बोलिए।
आयोजन समिति के सभी सदस्य और इसमें मुख्य रूप से डॉक्टर सुशांत मिहान जी, डॉक्टर अंशुमान जी, डॉक्टर परिमिता घोष, डॉक्टर वंदना मौर्य, डॉक्टर भूमिका उनियाल, डॉक्टर ग्रीन, जो नाम मुझे देखने को मिले थे यही है। मैं सभी आयोजक समिति के सदस्यों का धन्यवाद भी करना चाहता हूं और सबका अभिनंदन भी। मोतीलाल नेहरू महाविद्यालय के साथ मिल करके आप सब लोगों ने ये जो कार्यक्रम बनाया है ये समय के अनुकूल है और बहुत अच्छा है। हम लोग जानते हैं भारत सरकार की तरफ से घोषित आज़ादी का अमृत महोत्सव कार्यक्रम भी कर रहे हैं, किंतु मुझे बताया गया कि बहुत सारे दूसरे देशों के सदस्य भी इसमें शामिल हो रहे हैं, तो इस विषय को शामिल नहीं किया गया है। किंतु हम जो अपने देश के लोग हैं हम इसको इसके साथ जोड़ करके देख सकते हैं, इसमें कोई प्रॉब्लम नहीं है। मोतीलाल नेहरू महाविद्यालय के हमारे जो साथी इसमें जुड़े हुए हैं उनका मैं विशेष रूप से धन्यवाद करता हूं। हमारे जो एनवायरमेंटल साइंस के प्राध्यापक लोग हैं उन सब का भी विशेष रूप से धन्यवाद करना चाहूंगा। मित्रों, हम जिस मुद्दे पर बात कर रहे हैं सॉइल एंड वाटर असेसमेंट ये टॉपिक रखा गया है। जो पंच तत्व हैं जिनको हम पृथ्वी, जल, तेज, वायु, आकाश कहते हैं, इन सबका आपस में संबंध है। इसमें से किसी एक भी चीज को अलग करके नहीं देख सकते। विषय विस्तार की दृष्टि से भले ही हम किसी एक टॉपिक पर ध्यान केंद्रित करें, किंतु सभी विषय आपस में बहुत जुड़े हुए हैं। आप लोगों को कितनी जानकारी है मुझे नहीं पता, किंतु मैं एक संस्कृत का छात्र रहा हूं और मेरा अध्ययन क्षेत्र संस्कृति ही है और उसमें भी मैं गुरुकुल में पढ़ा हुआ हूं। इसलिए हमारा बचपन में कृषक परिवार में जन्म लिया गांव में, और हमारे गांव के चारों तरफ पर्वत श्रृंखलाओं का एक सुंदर वलय है, एक घेराव सा है। उसके पश्चात खेतों में रहते घूमते जंगल के सभी जीव जंतु प्राणियों से परिचय हुआ। उसके पश्चात गुरुकुल में गए तो वहां भी नेचर के ही गोद में रहे और जो पढ़ा हमने वो सारा का सारा पूरा का पूरा नेचर के प्रति समर्पित शिक्षा व्यवस्था थी। अभी आरंभ मैंने एक मंत्र बोला जिसका अर्थ यह है कि हमारे ऋषि मुनि लोग जिस बुद्धि जिस मेधा की प्राप्ति के लिए प्रयत्नशील रहे, वह मेधा बुद्धि हमको प्राप्त हो। तो कौन सी बुद्धि की वो याचना करते रहे, इसके बारे में हम अगर ध्यान से देखें, आप सब लोग विद्वान लोग हैं, सब जानते समझते हैं। हमारी सारी की सारी सनातन संस्कृति, प्राचीन संस्कृति, वेद तक भी सारी की सारी संस्कृति पूर्ण रूपेण, हमारा हमारा वेद हो, हमारा पुराण हो, धर्मशास्त्र हो, और अवांतरकालीन जितना भी हमारा महाकाव्य, नाटक आदि जितना भी है, सारा का सारा संस्कृत साहित्य प्रकृति के गोद में पला बढ़ा है। इसलिए प्रकृति के संरक्षण के लिए जितना चिंतन प्राचीन भारत के लोगों ने किया है, उस समय इसकी आवश्यकता नहीं थी। प्राचीन भारत में पर्यावरण को लेकर के बहुत चिंतित होने की आवश्यकता नहीं थी, क्योंकि कोई भी चीज प्रदूषित नहीं थी। किंतु आज अगर हम उन लोगों के चिंतन और उनके बातों को ध्यान दें, उनके बातों पर ध्यान दें, तो हमको समझ में आता है कि हजारों हजारों वर्ष पहले वो लोग हमको कितना सावधान करके चले गए हैं। ऋग्वेद, मैंने तो इस बारे में 2-3 आर्टिकल्स भी लिखे हैं बहुत पहले, जो छपे भी हैं। एक अम, जंगली पशु पक्षियों के बारे में है, और एक पेड़ पौधों के बारे में है। तो कहने का मतलब यह है कि हमारा वैदिक साहित्य से लेकर के अर्वाचीन संस्कृत साहित्य तक इन बातों पर ही जीता है, इन्हीं प्रकृति के संरक्षण में ही जीता है, प्रकृति के संरक्षण में अपने आप को आत्मसात करता है। वो प्रकृति से अपने को अलग करके नहीं चलता। उसका जीवन शैली भी, और उसका चिंतन भी, और उसका लेखन भी प्रकृति से ओतप्रोत होकर के ही रहता है। आप लोग विद्वान लोग हैं, और सॉइल के और वाटर के प्रदूषण के बारे में और उसके बारे में असेसमेंट करेंगे, क्योंकि मेरा ये विषय है नहीं और मैं कुछ इस बारे में जानता भी नहीं हूँ। किंतु जो मेरा विषय है प्रकृति, उसको मैं जानता हूँ, बहुत अच्छी तरह से जानता हूँ। मैं बहुत रुचि रखता हूँ, फार्मिंग में भी बहुत रुचि रखता हूँ। मैंने पिताजी के साथ जो है 2.5 साल 3 साल करीब खेती की है। तो पिताजी ने एक बार सोचा कि भाई सारे बच्चे पढ़ रहे हैं, इसको नहीं पढ़ाएंगे तो ये बाद में हमारे लिए समस्या बनेगा। तो उन्होंने जो है मुझे पढ़ने के लिए दोबारा से 3 साल के गैप के बाद फिर पढ़ाने के लिए भेजा। तो कहने का मतलब ये है कि हमारा समझ, हमारी जीवन शैली पूर्ण रूपेण प्रकृति से ओतप्रोत है। मैंने एक दूसरा मंत्र पढ़ा था, आपको ध्यान होगा कि सत्यम बृहत ऋतम उग्रम, ये अथर्ववेद में एक भूमि सूक्त है। अथर्ववेद के 12वें कांड में एक भूमि सूक्त है। ये पहले हम पढ़ाते रहे हैं, आजकल प्रिंसिपल बनने के बाद पढ़ाई लिखाई से थोड़ा सी दूरी हो गई है, किंतु हम इसको मैं पहले पढ़ाता रहा हूँ। इसमें कुछ चीजों की गिनती की गई है, शायद आप लोग इससे अवगत होंगे। मैं बहुत ज्यादा इसकी चर्चा नहीं करूंगा, क्योंकि एक मंत्र की व्याख्या में घंटों लग जाएंगे। किंतु मोटी मोटी बात मैं बताना चाहूंगा, जो जिसके बारे में कहा गया है कि ये चीजें पृथ्वी की रक्षा करती हैं, पृथ्वीम धारयन्ति, पृथ्वी को धारण करती हैं। तो उसमें क्या क्या चीजें हैं? तो सबसे पहली बात की गई है सत्यम, बृहत सत्य कहा गया है। सत्य तो सत्य है, बृहत सत्य क्या है? तो बृहत सत्य यह है कि जो सत्ता है, सत्य शब्द बनता है सत से। सत का मतलब होता है सत्ता, एग्जिस्टेंस, होना। तो किसका होना? प्रकृति का होना, हमारा होना, संसार का होना, ब्रह्मांड का होना। इससे कोई इनकार नहीं कर सकता, आपस में सब चीजें आप जुड़ी हुई हैं। तो ये जो अस्तित्व का सवाल है, जिसकी आप चर्चा कर रहे हैं, सोइल और वाटर, इसके साथ साथ और जो 3 महाभूत हैं, उनका भी, ये सारे हमारे अस्तित्व के आधार हैं। और उनका संरक्षण करना, जो जिस रूप में हमें प्राप्त हुआ है उससे और बेटर करना, उसको ना बिगाड़ें, ये इस बात से हमको समझ में आता है। दूसरी बात कही है कि ऋतम उग्रम। ऋत का मतलब नेचर, वह नेचर जो दिखाई नहीं देती है। जो नेचर दिखाई देती है उसको तो हम प्रकृति कहते हैं, किंतु जो प्रधान रूप नेचर है, जो दिखाई नहीं देती है, जो एक प्रकार का वैश्विक अननोन व्यवस्था है, वो जो ऋत है वह बहुत उग्र है। जहाँ कहीं भी कहीं कुछ गड़बड़ होता है तो वो बैलेंस करने की कोशिश करती है, जिससे कि हम इस पृथ्वी को या इस यूनिवर्स को समझने और इसमें रहने लायक बन पाते हैं। तीसरी बात कही गई है दीक्षा। दीक्षा का मतलब है कि वह भावना कि मुझे मुझे जहाँ जन्म मिला है, जिस धरती पर मुझे जन्म मिला है, उसके प्रति जो मेरी निष्ठा है, जो संकल्प है, जो व्रत है, वह बहुत जरूरी है और उसको यहाँ पर जो है दीक्षा कहा गया है। चौथी बात कही गई है तप। तप भी जो है वह भी प्रकृति को, पृथ्वी को धारण करती है। आप जिन बातों को यहाँ पर उठाएंगे, मुझे थोड़ा थोड़ा आइडिया है, और उसके संदर्भ में यहाँ पहले से ही वार्निंग दी गई है कि आप अपने सुख सुविधा के लिए या अनेक प्रकार के प्रयोजनों को सिद्ध करने के लिए, लाभ लेने के लिए जो प्रकृति का दोहन करते हैं, यह तप नहीं है। यह एक प्रकार की उस तपस्या का भंग है, तपस्या में विघ्न डाल रहे हैं। तप का मतलब यह है कि प्रकृति हमको जिन परिस्थितियों में रखना चाहती है या जिस प्रकार की परिस्थिति हमें प्राप्त हुई है, उस परिस्थिति में, उस प्रकृति में अपने को ढाल लेने का जो जीवन शैली है, उसका नाम तप है। उसके अगला है ब्रह्म बोला है। ब्रह्म का मतलब बहुत सारी चीजें होती हैं। ब्रह्म का मोटा मोटा अर्थ है बड़ा। तो ये जो भगवान है या ईश्वर है, उसको भी ब्रह्म कहा जाता है। वेद को भी ब्रह्म कहते हैं। और हमारा जो फिजिकल पावर है, इसको भी ब्रह्म कहा जाता है। तो ये जो इस इसका इसका सही संतुलित उपयोग करना बहुत जरूरी है। अगर हम इन तीन पावर को सही ढंग से यूज नहीं करते हैं, उसको संतुलित उसके संतुलन में हम अपने आप को नहीं ढालते हैं, नहीं जीते हैं, तो समस्या खड़ी होती है और पृथ्वी में अनेक प्रकार की समस्याएं खड़ी होती हैं। अगली बात कही गई है यज्ञ। अब यज्ञ का अर्थ अग्नि प्रज्वलित करके उसमें आहुति देने का ही नाम यज्ञ नहीं है। अगर आपने कभी किसी ने गीता पढ़ी हो तो देखा होगा उसमें कितने ही प्रकार के यज्ञों का उसमें उल्लेख है। तो यज्ञ का मतलब है कि जहां पर श्रेष्ठ लोगों की बातों को फॉलो किया जाना, श्रेष्ठ लोगों की अच्छी बातों को फॉलो करना भी यज्ञ है। दूसरी बात यज्ञ का अर्थ है कि आपस में मिलना जुलना, आपस में मिलजुल करके डिस्कशन करके संवाद स्थापित करके किसी नतीजे पर पहुंचने की जो प्रक्रिया है, यह भी यज्ञ है। यज्ञ की बहुत सारी डेफिनेशन आपने पढ़ा होगा, मैं उसके तरफ नहीं जा रहा। और ये जो तीसरी बात इसमें यज्ञ में कही गई है कि आदान और प्रदान, ये हम जानते हैं। हम अपने जीवन में अपने बचपन से लेकर के मृत्यु तक हर परिस्थितियों में हमारे साथ ये लेना और देना जुड़ा हुआ है। अगर यह लेना और देना, अगर हम सही भावना के साथ, सही समय के साथ, सही जगह पर, सही व्यक्ति के साथ, सही क्षेत्र में अगर करते हैं, तो इसको भी यज्ञ कहा गया है। तो ये जो यज्ञ है, यह भी पृथ्वी को धारण करता है। तो ये जो वैदिक बातें हैं, कल परसों मैं किसी का एक वक्तव्य सुन रहा था कि इतने लाखों वर्षों के बाद भी आज भी कोई भी व्यक्ति किसी भी मंत्र, किसी भी वेद के किसी भी वाक्य का विरोध करने की क्षमता नहीं रखता। यह इसलिए संभव हो पाया है क्योंकि उन ऋषि मुनियों का जो चिंतन है वह एक्यूरेट भूत भविष्य वर्तमान सबको विचार करके कही गई या अनुभव की गई बातें हैं। इसलिए आज भी उन वाक्यों को कोई चैलेंज नहीं कर सकता क्योंकि वो सार्वकालिक सार्वजनीन है, सर्वजन हिताय है, सर्वजन सुखाय है। तो ये जो यज्ञीय भावना है, ये जो पृथ्वी सूक्त है, इसमें आपको मुझे नहीं पता कि आपको कितनी जानकारी है, हमने तो पढ़ा है इसलिए पता है। इसमें पानी के बारे में भी बताया गया है कि पानी का महत्व क्या है, पानी किस प्रकार से हमारे जीवन का आधार है, कितने प्रकार की मिट्टियाँ इस धरती पर पाई जाती हैं। इन सब का वर्णन करते हुए अंत में यही बात कही है कि माता भूमि पुत्रो अहम पृथिव्या। ये सेंटेंस आपने सुना होगा। ये सेंटेंस इसी अथर्ववेद के इस भूमि सूक्त का ही टुकड़ा है कि माता भूमि पुत्रो अहम पृथिव्या। ये पृथ्वी जो है हमारी माता है और हम इसकी संतानें हैं। यजुर्वेद में मैंने यजुर्वेद को बेस बना करके 2-3 आर्टिकल्स लिखे थे। उसमें मैंने एक चीज देखी जो आपके साथ शेयर करना चाहूंगा। एक तो ये है कि वहां पर ना एक वनों के संरक्षण के लिए राजा द्वारा कर्मचारी नियुक्त किए जाने चाहिए या नियुक्त किए जाते थे, इसका उल्लेख मिलता है। आपको आश्चर्य होगा कि कितने पुराने यजुर्वेद और उसमें भी जो है ऋषि ये सोचता है कि राजा को वन के संरक्षण के लिए कर्मचारी नियुक्त किए जाने चाहिए। उस जमाने में वन की कोई कमी नहीं थी, सब तरफ जंगल ही जंगल, वन ही वन था। फिर भी उस समय ये भावना थी कि जंगल की सुरक्षा के लिए जो है कर्मचारी नियुक्त किए जाने चाहिए थे। उसी प्रसंग में एक और मजेदार बात लिखी है कि कभी भी किसी पेड़ को उखाड़ना नहीं चाहिए, लिखा है। माने किसी भी वन्य औषधि हो, चाहे कोई पेड़ पौधा हो, अगर जरूरत पड़ती है तो एक निश्चित दूरी से उसकी कटाई करनी चाहिए, जड़ से कभी पेड़ को नहीं उखाड़ना चाहिए। ये आश्चर्य होगा आपको, यजुर्वेद में ये मंत्र का टुकड़ा हमको प्राप्त होता है। तो ये फिर हमें उसके अवान्तर साहित्य में आते हैं, पुराण आदि में तो एक सेंटेंस बहुत पॉपुलर है, सब लोगों ने सुना होगा। एक दश पुत्र समो वृक्ष। पुत्र का मतलब पुत्रश्च पुत्रिश्च पुत्र ही होता है, मतलब पुत्र और पुत्र शब्द में पुत्र पुत्र दोनों शामिल होते हैं। तो सभी माँ बाप, सभी विवाहित जोड़े संतान की कामना करते हैं और संतान की कामना इसलिए करते हैं क्योंकि वो अनेक प्रकार के ऋणों से उन्मुक्त होना चाहते हैं। तो वहां पर ये बात जो
Okay.
कही गई है कि एक 10 संतान पालन पोषण करने से जितना पुण्य प्राप्त होता है, एक वृक्ष को वहां पर आरोपित करने से, भूमि पर उसको पनपाने से वह पुण्य प्राप्त होता है। कहने का मतलब ये है मित्रों कि हम सब लोग जहाँ जी रहे हैं, जिसमें जी रहे हैं, जिसके आधार पर जी रहे हैं, वह प्रकृति है। और प्रकृति के अंदर जो पंच महाभूत हैं, इन सब का हमारे लिए अत्यंत योगदान है, अत्यंत महत्वपूर्ण है। प्रकृति है तो हम हैं, प्रकृति नहीं है तो हम कल्पना ही नहीं कर सकते।
Wow.
इसलिए
Thank you.
हमारा जीवन
Thank,
उसी के साथ जुड़ा हुआ है। और आप सब लोगों ने मुझे इस प्रसंग में याद किया, इसके लिए बहुत बहुत धन्यवाद। मेरा विषय संस्कृत है, वेद से लेकर के अर्वाचीन संस्कृत तक हम इसी में जीते हैं, इसी में चिंतन करते हैं। तो मेरा तो वही सब रहता है। पता नहीं आप लोगों को मेरा ये भूमिका कैसी लगी, पर जो भी है आप लोगों
wow.
का एक बार पुनः पुनः धन्यवाद। फिर से सबका बहुत बहुत अभिनंदन। मेरी कामना है हमारा ये
Thank
कार्यक्रम
you.
एकदम सफल हो। धन्यवाद।
Thank you. Thanks a lot. Wow, 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 what a invocation and what a welcome remarks. And I can say thanks a lot, Professor Srivastava, for such extensive remarks. And those who do not know basic Hindi and Sanskrit in the language, so he was explaining about the basic scriptures where we have issues and problems and topics about the water and soil. And he explained about Vedic, Upanishad, other things. So we will talk more on that, and we will translate those welcome remarks into English to everyone. And he talked more about that. So today we are talking on soil water assessment tool, and it is clearly mentioned in the Brihat Samhita that that is written by Varamihir, as I know. There is a problem in soil, problem in water, but there are tools which can provide remedies for the soil and water problem. And that's how the soil water assessment tool today we are discussing is more about SWAT model. So I will over to Dr. Bhumika Uniyal. He will talk more about the modern tool of soil water assessment and the background we came to know about in the scriptures, and then the modern tool, Dr. Bhumika Uniyal will explain more. So over to you, Dr. Uniyal. You are muted.
Okay, I don't know how to. I cannot see. Okay, can somebody help me how to full screen the
In your
presentation?
bottom
So are you
right.
No.
are you doing two screens, Bhumika?
I'm
Are you
what?
doing the two screens or are you using a single screen?
I'm using the single screen.
So if you're using the single screen, right at the bottom, there should
No,
be.
the thing is this: I have a bar for the zoom in at the bottom, and I cannot do the. Can somebody tell me the command to?
So there
F5.
is no command, but you have to try
F5.
with it to be dragged.
No, F5 is not working.
Are you using Windows or
Can
Mac?
you send your
Yes.
PowerPoint to me or someone? We can project it.
Can you press the Windows button in your screen, and then you can see your PowerPoint, and then you can start.
She is using. Oh my God. Bhumika, send your presentation.
Yes. Now you can put in full screen. On the top, you can see the slideshow. Click slideshow and the beginning. Yes. From beginning. Yes, from beginning. Awesome. You are muted.
Sorry for this technical inconsistency. So now we start, and this whole session would be in English. I'm really sorry for the inconvenience which has caused to the listeners who were not knowing Hindi. So today I will give a course on SWAT where I will talk about the basics and model setup. I just wanted to know that am I audible enough, or should I speak a little bit more louder?
I think good.
Okay. So now I will talk about the contents which I will be discussing in the whole session. First, I will talk about the SWAT introduction, its application, and some examples where SWAT has been used worldwide. Then I will talk about the input data. Then I will talk about the input data and basic concepts. After that, we will move into the model interface, where we will be running a demo SWAT model. After that, we'll create a demo Q-SWAT model right from the beginning, where we will do watershed delineation and HRU delineation. So the last 3 steps, it is a hand-on exercise, and the first 2 sessions would be about theory. I'm really sorry, it would be a little bit more on the theoretical side today, but for tomorrow, everything would be basically, we will do everything into the Q-SWAT model. Now I will give a really brief introduction about the SWAT model. I know that everybody of you knows what it is, but just to brush up, SWAT stands for Soil and Water Assessment Tool. It is a watershed or basin scale model which runs on a continuous time step. It is developed by Dr. Jeff Arnold, who is working at USDA Agricultural Research Service. So this model is developed to predict the impact of different land use management practices on water, sediment, and agricultural chemical yields at a catchment scale. And I cannot see what is written at the last, so move ahead. Now this slide talks about the model benefits. So as we all know, that SWAT has started, or people are working with SWAT since 1980s, and since then it has been under continuous development. And because it's a long time until then, so it has accumulated a lot of people who are working with the SWAT model, and because of that, it has a global acceptability. And the second point we have here is readily available input data. So SWAT needs a lot of input data in the form of spatial and temporal data, and we can explore the globally available data sets. And there, apart from that, we also have some SWAT specific data sets which are freely available. User can, if data is not available, user can directly download those data and use it to develop SWAT model corresponding to the desired catchment which he or she wanted. Then the third point is SWAT model runs on a long-term basis. So this model runs on a continuous time step, and user can simulate the long-term impacts on water quality and water quantity for several decades on a daily basis. Then these outputs of SWAT can be easily interpreted if, say for instance, we are using R or Python or Excel, because the outputs are in the form of text files. So this can be easily put into any of the programs you are using, and then the results can be easily extracted. And once it's easy to extract, we can generate graphs, and then we can interpret the output more easily. Now, in this course, we will be using Q-SWAT, and here in the Q-SWAT, we have a specific visualization tab where we don't have to extract the model outputs. You could directly import the model outputs into the model and then create graphs. So this is a plus point for Q-SWAT. We don't have it in ArcSWAT. Now, the next point is regarding the model structure. Model structure is relatively simple. We have a really clear graphical user interface, which has a very good structure. Then the model is computationally efficient in terms of, like, if we wanted to model a Q-SWAT for really large basins, then it's not an issue. And we don't have to invest so much money and power on the computers. Then the last point what I wanted to discuss here is this model is open source model. So if somebody wants to improve it and use for a specific wanted to improve the model and use it for a specific case study, then that can also be done. Now I will talk a little bit about the model development. So this SWAT SWRRB model is the predecessor of SWAT model, which is developed from the combination of 3 different models. GLEAMS, which is a model corresponding to the pesticides, CREAMS, that is providing the daily rainfall hydrology component, and EPIC is providing the crop growth component. And apart from these models, SWAT also have an in-stream kinematics model and a routing structure involved. So that is the version of SWAT which we are using currently. And then there are certain other examples in which SWAT has been adapted more corresponding to a specific problem. Say, for instance, SWIM. It is a modified version of SWAT, which is developed by PIC Institute from Potsdam, and they're using SWAT models for flood simulation. Now, I will talk about the major components. There are quite a few, but I will name some of them here. So weather is one of the main component because that is the input of the hydrological cycle. Then we have hydrology, followed by the soil temperature and its properties. And then we have a module for plant growth, nutrient, land management, pesticides, bacteria, and pathogens. So I will cover most of them in the next slides. Now I will talk a little bit about the application of the SWAT model. As we all know that a lot of study has been done in simulating the stream flow by creating a catchment using SWAT model. So here I'm only talking about, I will not specifically talk about the stream flow, but here it's more about the impact of climate change on stream flow, and they have developed a SWAT for the upper Mississippi River Basin. And here on the left you see, so the model structure is like this. They have created 4 different SWAT models corresponding to different inputs. And then here on the right side, you see they wanted to see the errors in simulated stream flow and climate change. So the main idea behind this study is to check what is the error in the data which is taken from the RCM, and what is the error or what is the bias in the future data. So here, if we see the result, if we see this graph, so here we could see that the variation or the percentage change corresponding to climate is more than the error which is coming from the use of RCM and GCM data. That was the main takeaway point from this study. Now, I would talk about one more example. So here, Mr. Karim Abbaspur, they have developed a continental scale continental scale SWAT model for simulating hydrology and water quantity for the whole Europe. And then here they have used SWAT cup for calibration and uncertainty analysis for a high resolution large scale SWAT model. So this paper is providing a really nice protocol for calibrating large scale models. And if you are a beginner and you wanted to see the impact of certain SWAT parameters on, say, for instance, stream flow or nitrate, it is really nicely shown in this paper by giving a lot of examples. And they're also discussing about the limitation of large scale studies. So first, or the important limitation of the large scale studies is that we have a limited computational power from the computers. So in order to create these really big SWAT models, we need to simplify the model in terms of using the coarse, say for instance, using coarse resolution input data, say for instance, land use or soil map. Then they were also talking about that they have limited and uneven distribution of nitrate in discharge stations. In this study, they have used around 29 watersheds, which are present in the whole Europe. Then they were also talking about that when we do such a large study, then there is also limited information on management and reservoir operations. Then they were also talking about the lack of data on soil moisture and deep aquifer percolation. Then if we wanted to implement the agricultural management operation, it is also really difficult to get when we are using when we wanted to develop a SWAT model for such a large catchment. Then here so this is one of my study which I did in my PhD, and here we wanted to simulate the irrigation water requirement using SWAT model for 4 different catchments around the world. And here our idea is to first see how well SWAT is able to simulate irrigation water requirement under different agroclimatic zones. And then here you see, so this is the catchment from Germany. We have a catchment from India, from Vietnam, and from Chile. And the results show that model was giving good simulations corresponding to the stream flow. And also we have a low percentage deviation corresponding to the actual evapotranspiration simulated by the SWAT model. Then the main takeaway from this study was that the irrigation amounts were systematically overestimated by the model for the 4 catchments around the world. Now, apart from all those things, people are also using SWAT to simulate snow melt, and related stream flow dynamics. So here I'm showing an example where they wanted to assess the capabilities of SWAT model to simulate snow melt, and stream flow dynamics over an alpine catchment. SWAT only gives snow output in the form of snow water equivalent, which gives a depth in millimeters. In SWAT model, snow melt is simulated corresponding to the change in air and snowpack temperature. As I have already mentioned, that SWAT provides snow in the form of snow water equivalent, but here we only have so what people are or researchers are usually doing, they are simulating the snow melt from the SWAT model, and then they are comparing it with the globally available snow melt or snow cover data from the satellites. So here in this study, they have compared the snow water equivalent, which is simulated by the SWAT, against the MODIS snow cover data. And here you see in these 2 maps which are developed from the SWAT model and which is extracted from MODIS for 10th February 2005. So here what they have considered that if the amount of snow water equivalent is between 0 to 15 mm, then they are considering that there is no snow, and if it is more, then they are considering that it is snow. And here we see that from the MODIS, we directly get if there is snow or not. So we see that these 2 maps are very close to each other. And the takeaway from this exercise is, in order to simulate in order to simulate the snow melt, it is very important to incorporate the elevation bands over the mountainous catchments. And the result, as I have already shown, that SWAT produces a good spatial and temporal representation of snow cover in this alpine watershed. Now, another example is corresponding to the best management practices. So as I have already mentioned, that SWAT was initially developed to simulate the impact of land use management practices on sediment or water quality. So this is one of those studies. So here at first the SWAT model was developed, and the identification of critical erosion prone areas were done. once once the critical erosion prone areas were identified, then the selection of relevant best management practices were done, and the best management practices were defined corresponding to agricultural and structural ways, and then they were implemented into the model, and see how would be the reduction in the sediment yield from those best management practices. And here you would see the result that corresponding to the agricultural best management practices, there is less reduction compared to the best management practices corresponding to the structural. Then apart from just choosing the agricultural and structural best management practices, there was a combination of cost-based best management practices were also proposed. And here they were based ranging from low cost to high cost, and we could also see the reduction in the soil sediment yield at the end corresponding to the 3 scenarios. Then there are, apart from the examples which I have shown, there are other applications of SWAT model and many more. So say for instance, we are combining SWAT model with the MOT flow, where researchers are quantifying the groundwater flow or calculating the impact of groundwater impact of climate change and certain land use management practices on groundwater. Then recently people have been exploring the capabilities of SWAT to quantify ecosystem services. Then researchers are also using SWAT for quantifying or assessing the droughts in the future and also in the past. Then SWAT doesn't have a very good module for flood, but we could see the impact of flood into, say for instance, on water quality, water quantity. Then people are researchers are also using or assessing the hydropower plants present in a specific watershed by using SWAT model. And then this is really, yeah, people have been using it for so long, so like we need to see how much would be the impact of land use change on water quality, water quantity, and how it is developing in the future. So research is been going on. And then there is also an option that we could implement reservoirs and different reservoir routines into SWAT model and assess their impact. So, but this study, this list is not finished. There are certain things which I have surely missed, but this is the overall gist. Now I will talk about the strength of the SWAT model. So as I have mentioned already in the examples, that we could use SWAT for simulating a lot of different environmental processes. So so that's the best part of this model, that in one model, if I wanted to see the impact of climate change, land use change on stream flow, sediment, evapotranspiration, I could do everything in one model. Then this is a versatile model because it has been used for different watershed problems. Then based on this model, we could get a comprehensive information about the land use and pest management practices, and then based on the results of that model, policy can be improved. Then as I have already mentioned in my in the benefits of the SWAT model, it's open source and free to use QSWAT model, say for instance. Then we have a really large community which is working with SWAT. So and if somebody has some issues, we could just write in those Google groups, and people are really nice and they help each other. And then So since 1980s, there is a continuous development of the SWAT model by improving its code, and because it's a open source model, anybody could come up with a nice idea and that can be incorporated into the SWAT model. And for the information, I can also tell that currently we are using QSWAT, but we also have an improved version of SWAT model, which is called SWAT Plus, but that needs to be validated whether it's improved or not. But yeah, there are certain regions where it has higher capabilities than the SWAT model. Now, because I have told a lot good about the model, so it would not be justified if I would not talk about the weakness. So there are a lot of simplification which has been done in the SWAT model in terms of watershed configuration, representation of some processes. Say, for instance, in case of runoff calculation, we are using curve number methods. So these are certain things that could be improved. Then we have, say, for instance, flow and pollutant routing from the source areas to the streams are ignored. Say, for instance, in case of these source areas, we can only put them onto the river. We cannot put them onto this place where they are exactly present on the reality. That's the issue in the model. Then we have then the simulation of riparian buffers, wetlands, and waste management practices are limited. So like not everything is included, or not everything can be implemented into the model. That is also the weakness. Then this model, we cannot use it on all watersheds. Say, for instance, some watersheds have karstic area, then the response is like really fast, and in that case model has to be improved. So that is that is some weakness. And then in case of, say, for instance, arc SWAT, so the arc SWAT is much more stable, what I feel, is compared to the QSWAT model. Because say, for instance, because arc SWAT has been used for so long and QSWAT is like really new, and then the issue is also with the compatibility of QGIS and QSWAT. So here we have we would face, or one would face certain challenges if the QGIS and QSWAT are not compatible. So now I think I have talked enough, so we can go for a 5 minutes break. And meanwhile, what I wanted to say is, if you guys have not already installed QGIS and QSWAT, you guys can do it, so that in the next session we will use a demo model for demonstration, and you could also do it side by side when I am doing it. Thank you. Okay, so now I will talk about the basic inputs which are required by the SWAT model. It needs spatial and temporal data. So spatial data is in the form of GIS maps or spatial maps. So it needs digital elevation model, it needs land use and soil map. Once we put all those things into the model, apart from that, it needs temporal data in the form of weather. So say, for instance, it needs precipitation, minimum and maximum temperature, which is like really required. And if we wanted to use the Penman-Montier method for evapotranspiration calculation, then we need relative humidity, wind speed, and solar radiation as well. But if data is scarce, then model is able to work only with precipitation and maximum minimum temperature. Once we put everything into the model, then model then model runs on hydrological response unit. So these are a special combination of land use, soil, and slope. And once and all the model processes are performed on these hydrological response unit. And once we have the model, we could have the model outputs in the form of stream flow, sediment, evapotranspiration, whatever, and yeah. Then, so the input data format, how we need it to put into the model. So say, for instance, for the digital elevation model, we need a raster map. For land use and soil, either raster or vector map is okay. But if we are creating a SWAT model for a really large catchment, then vector map takes so much time, and the overall SWAT model becomes heavy, and then yeah, then it's recommended to use raster map when we are working with the really large catchments. Then apart from this, we need lookup tables. So these lookup tables are used to connect the map with the database. Then apart from a lookup table, we need soil properties, and then we need weather data, which is in the form of text files, or it can be in the DBF format. And I will show you all those data when we do the hands-on exercise. So if you guys don't remember this, then just don't worry. We will keep on using the same structure again and again. So it's not a issue that you feel that it's so much. So now I will talk some basic concepts. So here we are talking about the hydrological cycle. So as precipitation is happening, then certain part of the precipitation is taken by the canopy, and then when it falls on the ground, then based upon the soil moisture condition, some part is stored into the soil, and then the rest goes down or flows in the form of surface runoff. And then the part which goes down, then it can also come in the form of lateral flow, or it goes down or it percolates down to the shallow aquifer, and then some part of that which percolates into the shallow aquifer returns to the stream flow in the form of return flow. So this is how the hydrological cycle, which is represented into the SWAT model. So it has evaporation and transpiration component. Then it has a root zone. Then we have two aquifers, shallow aquifer and deep aquifer. And at any point of time, the amount of soil moisture present in the soil profile is equal to the initial soil moisture plus the water which is going out or which is coming into the soil. Say, for instance, rainfall is coming into, and then whatever is going out, that sums to the amount of soil moisture which is present before, and that's how the soil moisture is changing. Now, as I have mentioned, the main processes which is happening. So now I would explain how it is implemented into the model. So the canopy storage. So it is defined as the water which is intercepted by the vegetation, and this water is available for evaporation. In SWAT model, there are two ways to calculate the canopy storage. It is based upon the type of equation we are using for runoff calculation. Say, for instance, we are using SCS curve number for surface runoff quantification. Then in that case, canopy storage is defined as 20% of the retention. However, if we are using Priestley-Taylor for calculating the surface runoff, then there is a equation which is using the maximum amount of water which a plant or a canopy can hold, multiplied with the maximum leaf area index. So it's it is an equation which is changing corresponding to the plant, how plant is evolving. Then the evapotranspiration is a process of removal of water from the soil and also from the plants. So here evaporation is incorporated into the model where it is happening from rivers, lakes, soil surface. Then transpiration is the water which is leaving from the leaves, and then sublimation is also incorporated into the model, which is occurring in the ice and snow cover. Then we have infiltration and water redistribution. So based upon the soil properties or the amount of soil moisture in the soil zone or root zone, water enters into the soil surface, and then it moves through the soil profile based upon the amount of water a specific root zone or amount of water a specific soil profile holds. Then there is a lateral flow component incorporated into the model, and it uses a kinematic storage model. Then we also have return flow, which is coming from the deep water aquifer, and this is some percentage of the water which is going into the deep aquifer. Then we have surface runoff, which is calculated by using SCS curve number and Priestley-Taylor method. Now I will talk about the plant growth module. So here it uses an EPIC model, which is a single plant growth model for all types of land uses. Say, for instance, in a specific watershed, we have annual crops and we have perennial crops, but the model has a single growth, or SWAT has a single growth model for all types of crops. It works on a heat unit concepts where temperature is the most important for plant growth. Say, for instance, here you see a figure on your right. It shows the mean daily temperature variation daily from 1990 for the year 1992, and you also see a base temperature. So in the heat unit concept, the main idea behind this is whenever the temperature goes above the base temperature, only in that duration crop grows, or it accumulates heat units and then crop grows. So here, if we see this figure, so from here to here, we have a mean daily temperature which is more than the base temperature. So the crop growth will only take place during this period. Now, how model is calculating the biomass? So the potential growth under ideal growing conditions and actual growth due to environmental constraints. Say, for instance, a plant could have stress in terms of water, nutrient, and temperature, and then in that case, potential growth is not equal to the actual growth. And if we wanted to calculate the potential growth, then it depends upon the amount of intercepted photosynthetically active radiation, which is calculated by using this formula. And then we use this, or the model is using photosynthetically active radiation, and then calculating the biomass on that specific day. Then we move to the erosion. So for calculating the erosion, SWAT is using modified universal soil loss equation, where surface runoff is calculated by the method which a user is using into the model, and then peak flow is calculated by using rational formula, and then area is the model already has the area corresponding to a specific HRU. Then all these parameters which are required for modified universal soil loss equation, we have specific formulas for calculating it, and then the model is calculating the sediment yield corresponding to a specific HR. Now I would provide a little bit more information, about the nutrients, how nutrients are how nutrients are modeled in a SWAT model. So here it has two main processes. So SWAT use different processes and tools for nitrogen and phosphorus. Say for instance, in case of nitrogen, we have nitrogen in the form of mineral N and nitrogen in the form of organic N. Say for instance, we have applied organic N fertilizer, or this organic N comes from the plant residue. So then the active organic nitrogen goes into a mineralization process and then converts into nitrate, which is directly taken by the plant. And if we are applying inorganic nitrate fertilizer into the soil, then it comes in the form of NH4, which goes into a nitrification process and converts into NO3, and then it is taken up by the plant. And there is also another process which is called denitrification, that is converting this NO3 back to the organic, back to the stable N. Then more or less same process is happening in case of phosphorus. So two types of fertilizer can be given into the soil: organic P fertilizer or inorganic P fertilizer. And organic P is also coming from the plant residue. So the active one goes into the mineralization process and converts it into soluble phosphorus, which is taken up by the plant. Then, so here, nitrate or phosphate uptake by the plant is simulated by the supply and demand approach. So if the plant needs it, then plant takes it, and then if the concentration becomes less, then the organic nitrogen is converted into nitrate. So it's a supply and demand process. Then nitrate and organic nitrogen is removed from the soil by surface runoff. It can be leached with the water which is percolating down into this from the soil profile. Then it can also be removed with the lateral flow, and it also can be removed with the sediment. More or less the same can be seen in case of phosphorus. Soluble and organic phosphorus can be removed from the soil by runoff when it interacts with the topsoil, and it also, the major part of phosphorus, it removes with the sediment, because phosphorus is attached into the soil particles, and when water falls and sediment moves, then it also goes with the sediment. Now I will talk about the management operations that can be implemented into the SWAT model. All these management practices which are defined below, they can be implemented on HRU level in a specific watershed. So one can implement when a particular person wants to till the agricultural land, then we can also define what type of tillage equipment is used for tilling that particular piece of land. Then user can also define when the crop is starting, when the crop season is starting, and when we wanted to harvest the crop. Then we can also implement the timing and the amount of fertilizer and pesticide that has to be implemented into the soil. Then we can also define different irrigation applications. So like it can be either automatic or based upon certain rules. Then crop rotation is also can also be implemented into the SWAT model. Then grazing is also is automatic irrigation. We have also an option to provide automatic fertilizer into the model. Then we also have, so say for instance, in case of irrigation, a user can have an option to apply irrigation from different sources, not at the same time, but one could choose from which water source we need water to be diverted for irrigation. Then all those management operations can be implemented into the model by date and by heat units. So I will explain these tomorrow when we will implement these management operations into the model which we will prepare. So if you guys didn't or if you're confused with what are these heat units and how it will be implemented, we will implement it tomorrow. So just for now, you just remember that these are certain things that we could play with when implementing the management operations into the model. Now, I will move to the data which is provided. So when you would extract it, you would see there are two folders. One is demo model and other is input data. When you go or when you open this input data folder, then you would see a list of these files which are present in that folder. So this climate robot provides us the climate data. DEM has the digital elevation model, which we will be using for watershed delineation. Then you have land use map. Then this folder contains soil map. Then you also have lookup tables. So all of these we will be using for HRU delineation. Then you would also have information about the main outlet. Then this observed folder contains the observed stream flow data. And then you have one more folder named Droplet Streams, which has the information about the shapefile shapefile for the stream network. And we would be using all of them. And I will also show how it looks when you in how it looks in when you would extract it into your computer. So I will also show this. And for, as I have already explained, so for running, so now after the break we will run, or I don't know, see, yeah, so now we will run a demo SWAT model, and for that we need QGIS and QSWAT that should be installed in your PC. Then in the documentation which I have provided, so the date, time, and region must be selected as I have already shown you, because this model is developed in United States. So we need those region specific things that should be there in your PC. Then one thing which I wanted to tell, so this is sometimes this doesn't work if you have special characters or spaces into the folder path where you are saving your model. So that should be taken care of. So now if you guys are ready, then we can start running the demo model. Should I wait or should I start? Okay, so nobody's saying anything, so let's start. So can you guys see my screen? Could somebody say something?
Yes, Bhumika, we can see your screen, but it's still on PowerPoint.
And yeah, so now I need to tell that we are starting the demo model. So no, there is no PowerPoint. So this is the so here this is the data which was provided to you when you would extract it. So that's the input data and demo model. And here we would go to the demo model.
So
And
Bhumika,
then-
we are not seeing your screen, means we are seeing your screen and it's still on PowerPoint, but not on,
Okay.
yeah, it should be some other window.
Okay. So is it visible now?
Yes, it's good.
Okay. Sorry. So now, so this is the zip folder which you guys already have. So this is, and when you would unzip it, this would be seen like this. It has two folders, demo model and input data. So this is the input data. This is all about the input data, which I have explained in my previous slide. And I will also explain this in the next session. But for now, we would go to this demo model. And when you would open it, you would see demo_model.qgz. So this is a QGIS file. So if we would open it, a QGIS model opens. It would take some time. So here, okay, so yeah. So when you would open it, this is how it would look like. So the documentation which I have provided, you would already, I'm assuming that you guys already have QSWAT into your QGIS model. So if I would open it, so this it would look like this. So this is a QSWAT window, and here, so we go one by one. So here, if you go to about, you would have information about which version of QSWAT you are using and which version of QGIS is there and which version of Python it is using. Then here in the first site in here, you have an option to create a new project or open an existing project. And
So Bhumika, sorry
yes.
to interrupt. So you're still on the window where you were unzipping the QGIS project, but we are not seeing your QGIS screen.
Is it visible now?
Yes.
Okay, so maybe I go again. So when you would open, can you see the change of screen now?
Yes. So now it
Okay.
is back to the that
Yes.
folder window, demo folder.
Yeah. So this is, so when you go to this demo model, then there is a folder called demo.qgz. When you would open it, QGIS would open, and if you have a QSWAT installed, then you would see an icon here. Now, if you wanted to, so we would go one by one to all of the buttons here. So the first one, this tells about the information about which QSWAT version you are using, which QGIS version is required, and then which Python version it is using. And close. Then here on the second tab here, if we wanted to create a new project, then we can do by clicking this. And if we wanted to open an existing project, then this can be done by clicking this. So when we would open a new project, then these steps would not be visible. It is only visible because you already have a working QSWAT model. And then here on the left, you have the information about the QSWAT parameters. Here, if I open it, so here is the SWAT location of the SWAT editor, which is provided. Then this, so this provides the information. So like if I have a multi-core processor, then I could write, then I could give the directory, and then my process becomes relatively fast, but you don't have to use this. So you could just unclick it as well if we don't have any information about how many processor your computer is having. And then here we have the information about, then we have information about the certain reports, say for instance, elevation, because the HRU has been created. So we also have the information about land use and soil, and then for the HRUs. So now we go to step 3 for running the model. And then we need to first connect it to the databases. And then in order to run the demo model, we go to, I show it slowly. We go to SWAT simulation, then go to run SWAT. And then here, this window opens up. It is providing us the information about the start and end date of the model. So it's from 1st of January 1990 to the end of December 31st, 2013. And here we have a lot of options how we wanted to print out the output. So as I have already told, that model runs on a daily time step, but we can extract results on yearly or monthly basis. Then here we have an information about how many years we wanted to skip. So that is a warm-up period. So here I have given 5. Then we have a lot of options. So like if I wanted to print the soil nutrient, then I can just click this. And so whatever information a user wanted, that can be printed. So like if I click all of them, the model takes a little bit more time to run. Then we have here which output variables a user wanted to print. Say for instance, if I click all, then everything, whatever model is printing, it would print that. But if I would, if I want, so here in this case, it would print really less variables. But this is a really interesting tab where we could select which variables we wanted to print. Say for instance, in reach file, so these are the list of variables which model is printing. So then one can select. So if he or she wants the water which is flowing into the reach, water which is flowing out of the reach. So there are a lot of other parameters. We will talk about these parameters in the lecture tomorrow. Then one could also select parameter variables on the sub-basin file, then same as in case of HRU. The thing is why this is important, because if you would write all of them and run model on a daily basis, then if we wanted to open that text file, it becomes really big and we cannot open it. So then it is advisable to just print only those parameters which are required, and then at least you could open it without using R or Python. Then here we also have an information about which SWAT executable version we need. So like if we are, so like this is a 64-bit model. So, and then, so we have 2 versions, debug and release. So if we run the model with the debug version, and if there is an error, then it gives more information compared to if we run it with release version. And with release, it's a bit faster. So here I'm just selecting release, and then I'm running model on, so I wanted, the model is running on a daily basis, but I wanted to extract outputs on a yearly basis. And then in order to run it, first I have to set up, run, and then we run it. So here it's running for all the years, and then run is successful. So that's all for the demo model. We will develop it step by step after the break. Thank you for your patience, and I really hope that you guys are able to run the model with me. If you have any question, feel free to write, feel free to ask, because it is like really, really important that you guys work with the model and end up having a SWAT model, working SWAT model at the end of this course. Go ahead if you have a question. I don't know what exactly you mean, what we will get in the result by using the demo model. So like, so, okay, what you will get in the results by running the demo model. Okay, so here, okay, I share my screen again. So here, say for instance, I have chosen user choice. So the model results would have, say for instance, we have output in the form of output.reach that has results corresponding to flow input, flow output, or whatever is blue, I will get results corresponding to that. If I would choose all, then model will provide results for all the variables possible. Like now, if I would run my model, then I would have results corresponding to all the parameters, all the variables SWAT is giving results to. I hope it's clear now. Okay, is there any? Okay. Okay, it seems like people doesn't have link to the folder. Is it possible to, Dr. Gupta, is it possible to send them again?
I think I have already emailed the link to download all the data file. So maybe let me send again.
Yeah. So there was one who is asking, in ArcSWAT, how do we present a study area which is located in global south at right table section? Shashank, are you able to get this? What is the question? So in
Yeah,
ArcSWAT,
I am answering questions. I am beginning with Aries. So Aries, there will not be a separate session for data preparation. So this 2-week workshop is not for data preparation, unfortunately, but we will try to cater it later on. Peter mentioned in Oxford how to represent a study area which is located in the global south. So Peter, can you be a bit more clear in your question? What exactly do you mean by that? Because I think it's all depends on what kind of inputs are you using. So we don't usually give it as an specific input for right table section, because I don't know how you're setting your Oxford. A bit more information would be helpful to answer your question.
Yeah.
And then Tithi has asked, I have a reservoir in my watershed. How can I input the location? So when you actually delineate the watershed, Tithi, the first window, it tells you, or means it asks you for the point locations.
We will do this in the next session. So like,
Awesome.
yeah, we will do
So,
this. If you guys have any issues with that, we will do it.
and ma'am, we can model the lake. Yes, we can model the lake in
Yes.
SWAT. To know the nutrient retention. Yes, what type of model we will use? What kind of model? I think it's more kind of in-stream kinematics that you would be using, but I'm still unable to process your third part of the question. What type of model we will use? What exactly do you want to know? So there are in-stream kinematics model, means in-stream model that we will be using. I think it's equal to K. And other than that,
Yeah. Okay. So there is a latest question where somebody is asking about, is it, do you show step by step what data has to be? Yes. So this was just a demo model. I will explain all the processes which are included in creating a SWAT model right from the scratch. So it was just a demo to show you and to see whether your QGIS and QSWAT are compatible. So that's why I have provided a demo model, just to see if everything works well. So if this demo model is working well in your computer, in your PC, then there are high chances that the QSWAT model which we will prepare will work. So we will do everything step by step. So just don't worry. Currently, just run the demo model and see if it is working or not. That's all. Hello, sir. I have mailed you my output.std file. Okay, so there was one who was, I don't know. So to whom you have emailed your output.std file? To Sushant, you?
yeah, Bhumika, I think
Okay.
that person was talking to me, so
Okay.
I haven't received yet, but I'll check it. Means right now I'm trying to address questions.
Mhm.
I'll reply you back, Leeton, if I'm pronouncing your name right. So I have provided the Google link also in case you're not able to open up the Dropbox. For the irrigation alloys, I have already addressed it. So you can put those things in the management file or in the management operations. Pooja, specifically what type of module of SWAT? So there are not robust lake models within SWAT, but if you're more interested in in-stream kinematics, so what is right now working in a closed reservoir is called to, means it's not lake, but in streams. So it's called to K, but you always have provisions to make changes to the code as you need. So if you have a specific lake model you want to try with SWAT, you can modify the code you want and can bring up the code and can run it. Lake has not yet been studied that widely by SWAT, so lake is still a question for SWAT, but it can be used. Not open link, sir. It is opening for me, means definitely. So what did you try the Dropbox also? Sanchit, can we use SWOT model for lakes and reservoir for nutrient and element enrichment? Modified version of SWOT you can use, but not the public version. So there are few modified SWOT models that you can use. If you are interested, I can forward you some papers on that. So some researchers have modified SWOT source code for addressing the question you are looking for. Dr. Rao, can you please explain quick the model running? So Bhumika will be taking that stab. So can you suggest me
Then there is one person asking, SWAT can be used to assess future water availability. Yes. Yes, there are two global, two open source calibration programs in R. So you could also use those for calibrating SWAT instead of using SWAT cup model. If you want, I can put the link of them here. But if you go to the SWAT Tamu website, there it's available.
Yeah, Bhumika, I have addressed those questions. So
Okay.
SWOT plus R and PEST. So I have addressed those questions.
Okay.
Yeah,
Thank
so I
you,
think
yeah.
that question was Balaji's question. So if you can, Bhumika, if you can help Dr. Rao, he has some specific question about running. Can you quickly explain model running after opening demo model again, please?
Okay, yeah, I can do that.
So Peter, in case of data scarcity in some catchment, what's the solution to set and run SWOT? So if you have heard about soft calibration, Peter, so that could be something that you can do in the data scarcity regions. So SWOT is basically developed for that purpose only, for the ungauged stations. So if you know your watershed well, if you know, have a rough estimation, how should it behave like, you can do the soft calibration or the validation part once you set up your model. So can you please post sources, docs, Python console? So Dr. Rao, for Python console, you just need to call the executable. That is the only thing that you need to do. For other stuff for Python console, post any sources for running QSWAT. But we will share something regarding it.
So should I share my screen and explain the SWAT demo again?
I think so, Bhumika should go ahead.
Yeah. Okay, then. So is the screen visible? Yeah, participant now. So this is the folder which you would be downloading. Then once you would extract this folder, then you would have two more folders. So then in order to run a demo model, you have to go to demo_model folder. Here you would find .qgz file. You need to open it. Once you would click it, your QGIS would open. And if you have a QSWAT plugin already put into your QGIS, then you would see a QSWAT window here. And then yeah, and it would look like this. So here in this window, you have the information about which version of QSWAT and QGIS you're using. And then here we could select a new project if we wanted to create a new project, a new QSWAT project. And then if we wanted to open an existing project, that can be done by this. And if you wanted to run the demo model, you have to go to this step 3. You have to click edit inputs and run SWAT. Then you have to connect to the databases. Then here it says successful. Then we have to go to SWAT simulation. We have to go to run. And then here you could select with starting and ending date we are interested to run the model. Then we have a printout setting. So how we want our output should be in daily time step, in yearly time step, in monthly time step. So let's select daily here. And then here we need to choose which version of SWAT executable we want. So like if you're creating a model, you're running the model at first time, I would recommend using a debug running model with the debug executable, because there we get more information if there is some error into the model. But as this is running fine, so I will use this release version. And then here we also have a lot of information about which outputs I want to print. Say for instance, if I wanted to print the nutrient, if I wanted to print the snow output, so if I want to print these, I would just have to click those, and then it would model would be writing those. Then we also have the information about which output variables we want. Say sometimes we don't want all of SWAT to be printing all of them. Then here in here we could just select, say for instance, we only want water out, we want evaporation, and we want NO3 out. So then in that case, model is only printing those. So it's running all of them, all the processes, but it would only print these. Say for instance, in case of sub-basin file, we need these, so model will be printing these. And then you have to select OK. And then you have to do the SWAT setup, SWAT run. And once it is finished, you just have to click run SWAT, and then it runs for all the individual layers. And then you click OK. So I hope it's clear now. So what should we do? Should we take a 5 or 2 minutes break and then start with the next session, or should I just go ahead with the next session?
I think you may continue because
Yeah.
Yes.
Okay. So now you have already seen how demo model works. Now we'll develop QSWAT from the beginning, and for that, so is my screen visible? I hope it's.
Yes.
So now we move to watershed delineation. So I will give a little bit theory, and then we do the watershed delineation into the model. So first we talk about what is watershed. So watershed is defined as any surface area from which runoff resulting from rainfall is collected and drained through a common point. Here you are seeing a schematic diagram of the watershed. So all the water which is falling inside this boundary is draining corresponding to the outlet, which is, I'm really sorry, not seen. but yeah. And then watershed delineation is the process of identifying the drainage area corresponding to a set of outlets. So what are the essential data that we will be needing for watershed delineation? We need digital elevation model and the information about outlet. So like corresponding to what location we wanted to drain the watershed. Then there are certain additional data which is required, say for instance, stream flow network and user defined watershed that simply helps in developing a better representation of the watershed which exists in the reality. So now, these are the certain steps which we will be following for watershed delineation. So at first we create a new SWAT project. Then we would open a watershed delineation tab. And here at first we select the digital elevation model. Then we use a stream definition. I will explain why this stream definition is important. Then we will select outlet and inlet definition in step 4. After that, watershed, after that we click create watershed. So now we already have a watershed created, but sometimes it needs reorganizing. So that can be done by step 5. So we could merge certain subbasins which have a really small size. Then if we wanted to add reservoir or certain point sources, then we could also add, and then our watershed delineation is more or less done. So now we go to the model and develop a model and then create watershed. So here, so in order, is my screen visible?
Yes, yes, yes.
Okay, thank you so much. Now we will create a new project. So we go here for creating a new project, and here we need to give the location where our new project is saved. So say for instance, SWAT. And then you just have to save it. And once it is done, okay, once you have saved it, you would, why? Once it is saved, you would see the name of the project which you have saved, which you have given, and then this window will open. So you could see a difference. So in the demo model, I had like these 3 steps activated, and there was one step at the end, visualization. But here, because the model is not developed, that's why only step 1 is activated. So in order to delineate the watershed, we first click this tab, and here you would, now we need to follow certain steps which I have mentioned before. So here at first we need to select the digital elevation model. So you would click here, and then you have to navigate to the folder where your input data is present. So here the input data, and then we go to the DEM, and then we would select .tif. So this is, and once it is selected, you would see that you could see it here in your window. And if you want to have the more information, here we could see that this digital elevation model varies from 1785 meter above mean sea level to 2,182 meters above mean sea level. So now DEM is added into the model, and I have told you that we would use this burn-in existing stream network. So let's try to do this. And for that, we need to go back to the input data folder and navigate to the raw bit streams. And here, and then here we can choose, we can define the threshold. So here I have not changed anything, but we could also change here the area, say for instance 20, or maybe start with the figure. So the threshold 60, and then we create streams. It would take a while to create it, and then you would see the processes are going here. And now so this yellow was the burn-in stream, and the stream which is developed by the QSWAT model is shown with a blue. So here we could see that still, even if we have used a burn-in, we have used a burn-in stream, still the stream which is created by QSWAT model is different. Then here we could select the outlet. So here, so in this we have to go to we have to select .shp. When you would select it, you would see an outlet here, and then we have to then we selected again, then we checked it. So this, I did it wrong. So this click has to be selected only when we are drawing, and if we have the inlet outlet shapefile, then we can just directly upload it from this tab and then check if so. Here if we so this function, so usually a SWAT wants the outlet or location directly over the reach, but sometimes it doesn't fall exactly over the reach, so therefore there is a snap diameter. If it is lying around that snap diameter, then the model is considering it as a location. So here the snap threshold is provided as 300 meter, and then we can create the outlet, the watershed. Okay. So now here we see that our catchment is created. Don't know why it's not coming over. Yeah. Okay. Then I have also explained that if we want to restructure our subbasins, then we could merge certain subbasins by using this tab. So at first we need to select, say for instance, here. So here, if we click the select small subbasins, here we have two ways by which we could merge. We could merge based on the area, and we could also merge based upon the mean percentage of mean area. Say for instance, I wanted to merge based upon the area in terms of hectare, and let's select 10. And so here, if I click select, you see that there are two subbasins which are selected, and if we go here into the QSWAT interface, we see that this model is showing that we could select this, and we could merge these subbasins because they have an area less than the threshold provided. Then we go to save. As we save, this window would open, and then we could directly do the merge. So here it is giving us an information that you cannot merge a subbasin which has an outlet, inlet, reservoir, or point source. So say for why it is saying so, because here we have an outlet here, and previously it was showing that these two has to be merged. So if we would do this, then this will destroy the whole geometry of the basin. That's why a model is restricting us to merge these two. Then once it is done, if we want to add the reservoir, we could select the subbasin where reservoir has to be incorporated, or if we wanted to add a source, point source to each subbasin, then we can just click here and then add. So here this would add point sources to each of the reaches. This is important because in the case if we wanted to simulate the nitrate load, then we wanted to implement the water treatment plants, and if we have these point source included into the model, then we could put the amount of nutrient or the water which is coming out from those water treatment plants. Then it's more or less done. We could just we could just click OK. And it would just run and create our watershed. And how we could see that this is finished. Okay, and then we can cancel it. Oh, some difficulty. And then when we open, okay. Oh, yeah. So when the watershed delineation is done, the second step is activated. Now, maybe I go back to the watershed delineation again, and I would show you how we could add, how I could, so instead of using the output shapefile, I would just draw. So in that case, I just create the streams again. And then here I can select outlet or inlet. Say for instance, then right one. Maybe I start right from the beginning because somehow it's not working. So let's start from the beginning. Let's see. It was, yeah. So then we burn in streams. So let's this time we choose a small threshold. Okay, so instead of using, we draw the outlet and then here we have selected an inlet, an outlet, and then I would also like to show you. Let's select an inlet point as well. So here, so the direction of outlet is towards the river upstream, and the direction of the inlet is towards the downstream. I would show you why the importance of adding inlet. So now, okay, and now as we have draw the inlet and outlet, we have to select it. So like select, and then we just have to. So as soon as it is yellow, it means that they are selected. Then we have to save it. And here you see that the one inlet and one outlet is selected. And in order to be sure that it lies into into the area where model can take it, I need to check whether it's in the snap radius or not. I checked it and it's present, and then I create the watershed. Okay, so it is saying that because I have the last time I have the outlet thing, so I just have to click OK and then click create, and then it works. So, seems like it doesn't work. Okay. Seems like it's not working. Let's try it again. If it doesn't work, then I create a new. There is no error. I have no idea why it's not working. It's done. Then we draw. Okay. Now there is a okay. So I think it's a good idea to create a new because somehow it's not working. Wow. Okay, this part. I'm really sorry. I'll create a new one to show you the inlet and outlet things because I have no idea why it didn't work. So now we do right from the beginning. We create a new project. SWAT project. Draw outlets. Then we save it. We see the dealing watershed tab again. Click it. We go to selecting digital elevation model. You see it here. Then we choose the burn-in stream network. Go to Robot stream. Then here we can select hectares and then 20, and then we can create the streams. Then we can draw outlet. And then we draw the inlet. I've already explained the directions. Then we have to select them. Once they are selected, it would be yellow, and then we have to save the selection. Then we checked, review snapped, and I hope it works now. So we create the watershed. I failed to remove all outlets. And now it has somehow created, but what I wanted to show you, it's not that. But let's so select the sub-basin. We can select it based on the area. So here it has selected 6 sub-basins. Go to save and then merge. Okay, so here it's saying that this sub-basin 108 has upstream inlet and downstream one. So like here, so the thing is this, somehow here I have selected inlet point, and here I was selected the catchment outlet, and usually the section which is selected, which is contributing to the inlet, it becomes a different color, it becomes black. But here in this case, it's not happening. I will get back to this again and tell you this tomorrow. But this is the reason why it's saying that this merging is not possible. Then we can, and it does not merge. And then if we need to add the point source, we could add the point sources to it, and then we click OK. And then catch it. So now now you see. So this, the black thing is the inlet. Model is not simulating it. So whatever the subbasins are present here, what we need to do is, it is creating an inlet file, and then we need to add the, say for instance, stream flow, sediment, nutrients corresponding to this point, and from that point model is simulating. So this is how the if we wanted to give the inlet, this is how it works. And now we quickly move to the create HRUs. I hope that until now it's clear. Sometimes this QSWAT has some issues. That's why it's good to close everything and create a new project. Yeah. So now we start with the HRU delineation. So for the HRU delineation, maybe I just quickly go to the presentation. So for HRU delineation, we need a land use map, soil map, lookup tables, and we also need to provide the information about the slope classes. There is also one function which is providing us that we could split a specific land into certain crop types, but I will discuss this, and if we have time we could do it today, or we can do it tomorrow as well. So now I would like to show you how spatial map is. So this is the land use map, and if you would open the attribute table, you would see the legend attribute table like this, and that has a legend 1, 2, 3, 4. And if I open the attribute table, then this legend, this value is corresponding to a land use code into the SWAT. And more or less a similar thing we could see in the soil map. If I would open the attribute table, I could see a table value, and then this value is corresponding to a soil type, which is which we have to add into the model. So this is the QSWAT Ref 2012, and this is the model database, because this as this model is developed for United States, and our model is not present in United States, so therefore we don't have the soil information. Therefore we need to add that. I would also show you this very quickly. So and then this is how the slope class is defined into the SWAT model. So slope is calculated as a percentage, and this is like height divided by length. So what we do in the HRU delineation, first we will add the soil, the land use map, then we select the soil map, then we select the databases in the section, then we need to input the slope classes, then we read the lookup tables as I have explained. So these lookup tables are used for connecting the soil, the maps with the databases. Then we define the HRU threshold, so like how we wanted to create the HRUs, and then we create HRUs, and then there's an optional tab where we could split a specific land use corresponding to specific, say for instance, agriculture can be split into corn and winter wheat, say for instance, and then the last step is we create the HRU. So now we move to the model itself there. So at first we select the land use map. So here in the input table, we go to the land use, then we select this .tif, and so we can check it. So we can check it here, it's there. Then here in the land use table, we have to select use CSV. So this is the information we are providing to the model, that the model should use the lookup table which is provided by us. Then we need to go to select the soil map. We go to this, and then we need to select use CSV. Before moving further, we need to update the user soil database into the model. So this is my model, SWAT _project _draw outlet. So that's the name which I have chosen. And here you see a QSWAT reference 2012.mdb. So this is a database which SWAT is using for extracting the land use and soil properties. And here, because our soil data is not present in this database, so we have to copy it there. So you have to find out user soil, and then you also have information about the user soil that has to be put into the model in this lookup folder. So if you would open it, and then you have .xlsx file. So you have to open it and just enable editing. So you just copy it from here. Let's see. Okay, open it again. Yeah, and we just have to paste it here. Not successful. Somehow after saying no or yes, I think it worked. Yeah, maybe I can quickly check if it is there or not.
So Bhumika, just a suggestion here.
Yes.
Since we are already half an hour above the allotted time, so is it possible for us to have this HIU module tomorrow along with the rest of the activities?
It's definitely possible, but it's more or less done. If or we can do it tomorrow as well. So no issue.
Okay, means I'm fine, but if anybody has to leave, they may. But if you want to stick back, you may.
Yeah, maybe then we can do it tomorrow. No issues.
Yes, and from my side, I will send the link to join tomorrow's session. So, dear participants, so please visit your email ID. I will send you the link by evening to join our second session. Okay, thank you very much, Dr. Bhumika ji and Sushant ji, for such a great talk today morning. And what's about the screen recording? Yeah, we will definitely provide you the recording if necessary or if needed. For the time being, you have to attend the session. We are not going to upload on the YouTube immediately after the session, because Otherwise, people will leave the session and they will wait for the YouTube link. So instead of YouTube link, please join us, and we'll send you the link for tomorrow. Thank you very much, Bhumika.
I wanted to add.
Yeah.
Sorry, I wanted to add. I'm really sorry for the not keeping the time. You know that these models and everything, sometimes it works really well, and sometimes there are certain issues. So yeah, we need to keep this in mind that yeah, these things come up, and I really wanted to yeah, explain whatever I know, and my only motivation is that at the end of this course you guys would able to know all the inputs, outputs, and how, at least how to develop the model at the end. Troubleshooting is another thing, but at least you guys know that where to click and what is what. So thank you so much for your time and attention, and have a good day, and see you tomorrow.
And good night for both of you. Take care, everyone.
Thank you,
Take care.
Pankaj.
Bye.
Thank you, everyone.